Hello and welcome to Effortless Mastery. Today we'll be discussing on the chemistry of amino acids. Who are amino acids? Amino acids are just the building blocks of proteins, which are one of the macromolecules we have in the human body. Now, what should we know about amino acids? Very quickly, the structure of an amino acid. What are the key things I see in an amino acid? From the name amino acid, there should be some form of amino group in this compound, and there should be a form of acid. Of course, in organic chemistry, that's carboxylic acid functional group. Now, so when you look at the structure, what it has is one is central carbon, also called the alpha carbon. Alpha is the carbon next to the functional group. So when we look at carboxylic acid, if we are looking at this structure, this will be the functional group. The first carbon after it is called an alpha carbon. All right, so that first carbon, which is an alpha carbon, also is the same thing as the central carbon atom here. Number two, there is an amino group. Number three, there is a carboxylic group. Number four, there is an hydrogen atom. So this is something we see in all amino acids. The only thing that makes one amino acid different from another is the particular side chain you have. So if the side chain is hydrogen, for example, the amino acid you are dealing with will be glycine. But if it is, the side chain is now maybe a methyl group, that is CH3, the amino acid you'll be dealing with will now be alanine. So this same structure is what we have for all amino acids. There will always be a central carbon, carboxylic group, hydrogen, and amino group. The only thing that makes it one amino acid different from another is what? The side chain, which is the alkyl group R. Now, next up, what are key properties of amino acids I would like you to take note of? Number one is that the amino acid portray, all amino acid apart from glycine portray a characteristic we call chirality. Now, chirality, what's a chiral center? A chiral center is a point in the structure where, if you look at a particular carbon atom in that structure, it has all the four groups around him are different groups. Listen very carefully. So that when I look at the structure of an amino acids, let's pick glycine, for example. There will be that central carbon, there will be COOH, there will now be the NH2, there will be hydrogen, but glycine will still have hydrogen. If you look at this alpha carbon, you would observe that this is a different group, but these are the same groups. So this is not a chiral center. That's why glycine is not chiral. It is not chiral. But if you look at something like alanine, this is alanine, NH2, central carbon. Of course, you should always have central carbon, carboxylic amino acid, amino group H. But its own side chain is CH3. So if you observe, this is a different guy, different. That characteristic is called chirality, and it's something all amino acids portray except glycine. Now, because of chirality, they can do optical activity. Optical activity is when you can have, so they could switch. So this compound can exist in two different forms, usually D and L. And please, the isomers we have that is more common in the human body in our diet is the L amino acid. Please take note. If we're dealing with carbohydrate, I would have mentioned that the carbohydrate that is the isomer of carbohydrate that we have in a human body, or that is useful to us as man, is D-glucose. But when I come to my amino acid, it is L amino acids. L amino acid is more important to us. Then also for the acid-base property, if you observe, the amino acid has a carboxylic end and a basic end. So that means it can show both acidic properties and basic properties. So if you are in a solution, an acidic solution, that's a solution where the pH is low, what do you expect? In a solution where the pH is low, that's an acidic solution. The acidic solution will always be bringing H+. And you know what an acid is? An acid is someone that will donate hydrogen ion. A base is someone that will take it on. So if you observe from this structure, if I am in an acidic medium, what is an acidic medium? An acidic medium is a medium of low pH, which is also the same thing as high concentration of hydrogen ion. So if it is plenty, the part of the amino acid that will react with it will be the basic end. So that when it picks up this hydrogen ion, what I'll be having as a structure will now be NH3+. So you realize that in acidic conditions, the hydrogen ion will attach to the amino group so that we'll always be having the amino acid exist as a cation. So please note, whenever we are in an acidic condition, amino acid exists as what? Cations. Now, in basic condition, what are we expecting in basic condition? More of OH minus. So when there's OH minus, my carboxylic N will lose its hydrogen atom. So once it gets rid of hydrogen atom plus OH will form what? Water. You know, water is neutral. So it is not a problem. So once that happens, what do we expect to see? We expect that if I'm dealing with glycine as the amino acid here, when it is in the presence of OH minus, this will now be lost. And the compound will exist as what? An anion. So please, in acidic conditions, hydrogen ion is what we have in the solution. And the amino acid will exist as a cation. But in basic condition, OH minus is what I have in the solution. And the amino acid will exist as what? A base. So that's why we say amino acids or proteins generally can act as buffers. Now, but there is one pH which is very important, where at neutral pH, you realize that the amino acid can act both. So at a neutral pH, it can exist in two forms. So it can act both as an acid, which is losing hydrogen, and both as a base, gaining hydrogen. So at this point, we can say that amino acids exist as Zwitter ion, or you can say dipolar ion. But I think I would like the word Zwitter ion. So what do we say is Zwitter ion? When it is existing both with positive and negative. And if you observe, plus and minus is the same charge as zero. So it is having a neutral charge. It is called Zwitter ion. Zwitter ion. Now, at that pH where we have this neutral charge is called isoelectric pH. The pH where we have both positive and negative, giving us a neutral charge of zero, is isoelectric pH. Of course, I mentioned earlier that in acidic condition, you have H+, and so you'll be having a positive guy. In basic, you'll be having a negative guy. So that's for that. Now, also, you should, on all of these things, from what I've said, you observe that amino acid can act both as an acid and as a base. So for that reason, we say they are amphoteric. Now, what are the classification of amino acids? Now, they are classified based on three criteria: nutritional requirement, nature of side chain, and metabolic fate. For nutritional requirements, we have some books would say 2, some would say 3. Now, I will use 2. We have essential amino acids. We have non-essential. And some books will make addition of semi-essential. What are essential? The things you require in your diet. That means the body cannot synthesize those amino acids, but it is always required in your diet. Non-essential are the guys I can synthesize. So whether they're in food or not, is not a problem. Now, so for the essential, I have an acronym for it. And the acronym I use is try this VIP mole. So I'll just rush over it. Try this VIP mole. Try is the amino acid tryptophan. T here is the amino acid threonine. HIAC is the amino acid histidine. V is valine. I is isoleucine. P is phenylalanine. M is methionine. A is arginine. I am underlining A because I will say something about it. L is leucine. The last L is lysine. So I go again. For essential amino acids, these are people that we cannot synthesize in our body, so they are required in our diet. Tryptophan, try. Threonine, histidine, valine, isoleucine, phenylalanine, methionine, arginine, leucine, and lysine. Arginine is usually regarded as semi-essential. Some people even add histidine as semi-essential too. What do they mean? At some points, they were essential, especially, I think, at early life, they were essential. That means you require them in your diet. But as we age, we no more really require it again. That's where arginine comes in. Now, every other amino acid is non-essential. So you should know the list of all the amino acids. Then you now know who is essential. Then you can tell who is not essential. The next thing is based on the nature of side chain. So based on the side chain. Now, if the side chain contains carboxylic group, that is beyond this carboxylic group we have here, if the side chain contains carboxylic group, it is called an acidic amino acid. And there are two examples, glutamic acid and aspartic acid. You realize in their side chain, there is carboxylic group. Number 2, If in your side chain there is an amino group that is beyond what I have here, if I have carboxylic group, I say it is what? An acidic amino acid. And that is who? Glutamate and aspartic acid. If I have an amino group in your side chain, you are a basic amino acid. And we have 3 examples all. H, histidine, A, arginine, and L, lysine. All three are basic amino acids. So that's based on the nature. Then lastly, there are people that are neutral. So they are neither acidic or basic. So in their side chain, you don't see those carboxylic group. So those ones are now called neutral. And this neutral is divided into 2. Neutral polar and neutral non-polar. Neutral polar and neutral non-polar. An example of neutral non-polar would be someone like glycine. An example of neutral polar would be someone like threonine. So you realize that when you look at their structure, their side chain, observe the difference. The side chain of neutral non-polar, first they are neutral because they don't have carboxylic acid or amino group. But why is it now non-polar? In their side chain, it is not, how would I put it? You know what polarity is now? There's difference in electronegativity. You don't have it there. So you'll be having side chains like hydrogen in glycine, CH3 in alanine. Those are non-polar, neutral non-polar. But neutral polar, an example would be someone that has methionine, threonine, who have OH in their side chain. Now, lastly, is now classification based on the metabolic fates. We have 3 classifications here. Can either be ketogenic, glucogenic, or both keto and gluco. What do we mean by all of this? The amino acid can be used to, during in metabolism, the amino acid can be used to form a glucose alone. That's called glucogenic. Can be used to form ketones. Ketone, but that's called ketogenic. That's entering the ketogenic pathway. Lastly, can be used for both. So the example for only ketogenic is the 2 L's, which is leucine and lysine. Only ketogenic is the 2 L's, which is leucine and lysine. Then for both ketogenic and glucogenic, I like the acronym AIT. AIT. The A here is your aromatic amino acids. I is isoleucine. T is threonine. But the question will now be, who is A? I said aromatic amino acids. Who are the aromatic amino acids? There are 3 of them. Phenylalanine. So in their structure, you have the benzene ring. Phenylalanine, thyroxine, and tryptophan. So that is just that for the chemistry of amino acids. So the key thing we are noting is the structure, the key properties, and the classification. So for the classification, there are 3 criteria of classification, and you must know all of them. Take note of what Zwitter ion is. I believe you understood what we did today. Yeah, I know how to hurry through it because of time, but I believe you understood. If you have any question, do well to mention it in the comment section. Do well to comment, like this video, share it to as many people as possible. Trust me, here at Effortless Mastery, we are here to make your medical journey very easy. So no matter what you are struggling with, we can make it easy. So if you have questions or you have topics you would like us to discuss on, please do well to mention it in the comment section. Thank you so much for joining us today.